Hello, and welcome to Mereco Technologies video presentation. The topic for today's presentation is resin shrinkage. This is a property that Mereco is very interested in because customers need to know when a resin system cures from a liquid state to a solid state, there is a certain amount of shrinkage that accompanies that cure. Customers need to know this because it might relate to the ease of demolding the resin part from a mold. It might also relate to the shrinkage of the resin and how it affects, let's say, an embedded component that might be encapsulated by the resin. The technique that Mereco uses for measuring resin shrinkage is to first measure the liquid specific gravity, cure the material to a solid state, and when the solid is available, the solid specific gravity is measured. The liquid and the solid specific gravities will differ due to resin shrinkage, and by knowing the difference in these values, you can calculate the resin shrinkage, which will be explained a little later. The first step in measuring resin shrinkage is to get a resin system that has been mixed with, let's say, the base component of the resin and the hardener component. You mix those together. Then you must vacuum de-air that particular material. Resin densities are really only valid when there's no air in the resin that would interfere with the value that you get. So the resin system must be vacuum de-aired before you can do either the liquid density, and then the solid that you pour from that resin will also be vacuum de-aired. One of the tools that Mereco uses to measure liquid resin density is this particular device. It's called a weight per gallon cup. It has the ability to pour resin into it. There's a hole in the lid. When you put the lid on, some resin should come out. When resin comes out of the cup, then you know it's totally full and you can get the weight, and we'll explain what the weight means a little later. The first step in measuring resin shrinkage is to determine the density of the liquid resin. This particular system consists of the resin and the curing agent mixed in the proper proportion. The components must be around 25 degrees C. I usually specify 25 to 25.5 degrees C. That way everything will be measured at the same temperature. It's important also to vacuum de-air your mixed resin material. Any extraneous air that is left in the sample will certainly influence the density, so the idea is to get the air out. We use what is called a weight per gallon cup. This has a fixed volume inside. It's manufactured to very exact specifications. I will first determine the weight of the empty cup. That weight is 19.82 grams. I will then start pouring resin into the cup. The idea is to fill the cup with the resin. When it's full and resin comes out the hole in the top lid, then you know the cup is full with the exact volume of resin. Put the lid on. We are getting resin coming out the lid. Wipe away the excess resin so we only have resin inside the cup, none outside. We'll determine the weight of this filled cup. (27.85 grams). Once the weight of the cup and resin has been determined, the process continues with transferring the resin to an aluminum dish to cure it. This aluminum dish is now ready for curing. The operation now is to cure the resin. Normally it can cure overnight, let's say, if it's a room temperature system, or If it's an oven cured system, you would put this aluminum dish in the oven for the stated temperature and time that the supplier recommends. The next step in measuring resin shrinkage is to get the specific gravity or density of the cured resin. This is a sample of that resin which was placed in the oven for curing, and it's now a solid material. It's actually a flexible silicone, so we'll be able to easily bend it and put it in the measuring cup. This particular cup is also a weight per gallon cup. It has 10 times the volume of the smaller cup that we used earlier, and the reason we use this is it has a lot of water, so you can easily measure the water displacement. We will first establish the weight of the empty cup, 130.29 grams. We will now fill the cup with water using the same technique of pouring water in, putting the lid on, and having water come out of the hole in the top, in the center of the lid. I have some water on the top of the cup. I'm going to wick it away with some paper towels. The cup must obviously be dry of all water on the outside of the cup. The only water we care about is water inside the cup. The weight of the water plus the cup is 213.80 grams. The next step in measuring resin shrinkage is to get the specific gravity or density of the cured resin sample. We will measure its weight first, and then we will use the technique of water displacement to measure its volume. Tear out your scale, put the resin on. The resin sample weighs 7.80 grams. In order to allow room for the resin inside this cup, we'll pour out a little bit of the water. This flexible silicone we can fold over, immerse in the cup. We will want to fill the cup with water, so water again comes out the hole in the top. That's the only assurance you have that the cup is full. Put the lid on. A little bit of water did come out. We'll dry up the excess water again, making sure that the only water that we're measuring is the water inside the cup. No water outside the cup. The weight of the cup plus the water plus the sample, 213.90 grams. We now have all the data we need to calculate resin shrinkage. The various steps about resin shrinkage will be shown on the next few slides. To measure liquid resin density, we recorded two weights, the weight of the empty cup, then the cup filled with resin. A simple subtraction of the cup weight from the weight of the cup plus resin gives you the resin weight 8.03 grams. Because we used a weight per gallon cup, this weight can be converted to 8.03 pounds per gallon as the density of the liquid resin. Dividing by the density of water, 8.345 pounds per gallon gives you a specific gravity of 0.962. The density of the cured resin material was measured by recording four weights: the weight of the empty cup, the cup filled with water, the sample weight, and the final weight was cup plus water plus sample. Each of these figures is used in the calculation of solid resin density, as you'll see on the next slide. To calculate solid resin density, you first determine the weight of water in the cup by subtracting the cup weight from the cup plus water. You can then convert this weight, 83.51 grams, to 83.51 cc's, using the fact that water density equals 1 gram per cc. When the sample is put in the cup, some water is displaced. You determine the weight of water in the cup when it has the sample in it to be 75.81 grams. You again can convert this to a volume of 75.81 cc's using the water density equal to 1. The volume of water displaced by the sample is then 83.51 cc's minus 75.81 cc's. 7.70 cc's is the volume of the resin sample. The density of the cured resin is therefore 7.80 grams divided by 7.70 cc's, 1.013 grams per cc. We determine volume percent shrinkage by using the liquid resin density and the cured resin density. You can start out by assuming a basic weight of material, let's say 100 grams in this case. The volume of liquid resin is 100 divided by 0.962, 103.95 cc's. The volume of solid resin is 98.72 cc's. The decrease in volume during the cure is therefore 5.23 cc's. This is 5% of the starting volume of 103.95 cc's. So we now have our volume percent shrinkage. Once you have the volume percent shrinkage, you can then calculate a linear percent shrinkage, basically by assuming that the volumes of materials that you had were, let's say, a basic cubic shape. The length of a side of the cube for liquid resin would be 4.701 centimeters. The length of a side for a cube of solid resin would be 4.621 centimeters. Therefore, the decrease in length of the material during cure was 0.080 centimeters. This is 1.7% of the initial liquid length, 4.701 centimeters. So in summary, our silicone material had a volume percent shrinkage of 5% and a linear percent shrinkage of 1.7%. Thank you for watching today's video presentation on measuring resin shrinkage. I hope this information is helpful to you in your business and your applications, and stay tuned for further Mereco video presentations. Have a good day.